All right, if v of t is, say, a velocity function in feet per second, then what are going to be the units of the integral of v of t dt? Well, when we think about this part of the integral, the units there are going to be in feet per second. And dt, that's with respect to time, and time in this case is measured in seconds. So if we just look at the units, this thing should simplify to being feet, which means the integral of velocity is going to be a distance. And similarly, let's say that v of t now is measured in miles per hour. That means that this part is going to be in miles per hour. And this part of the integral, the dt, will be with respect to time, and time is measured in hours. So again, this will simplify to being in miles. So the integral of velocity is going to be distance. Thinking about these rates not as necessarily a speed, but if w of t is measured in cubic centimeters per minute, then the integral of w of t dt, this part of w of t, would be measured in cubic centimeters per minute. And with respect to time, means time is measured in minutes. So our result of this rate is going to be a volume of cubic centimeters. And let's say w of t is a work function, then the integral of w of t dt, this part, would be measured in jobs per day. And the time is measured in days. So when we take the integral of the rate, jobs per day, we'll be left with just jobs. Okay? That's the first thing. Now let's take a closer look at the particle problem. Right? The velocity of a particle moving along the x-axis in feet per second is given by v of t equals t squared minus t minus 12 for time going from 1 to 5 seconds. Find the net change in the particle's position over this time period. So what we're asked to do is really just to find the distance when we're given a velocity. So we know that to find distance, we would just take the integral of velocity with respect to time. And our time is going to change from 1 second to 5 seconds. So we're going to find the integral from 1 to 5 of t squared minus t minus 12 dt. And now it's just a bunch of calculating. We'll calculate the integral, which will be 1/3 t cubed minus 1/2 t squared minus 12t, evaluated from 1 to 5. So we plug in 5 first. That'll be 125 thirds minus 25 halves minus 12 times 5, that's 60. And subtract. Substituting 1 now, we'll have 1/3 minus 1/2 minus 12. And when that's all said and done, that'll be negative 18 2/3, or negative 56 thirds. Now the important thing to remember is that what that means is that this is the net change in the particle's position, which means the particle is going to end up 18 2/3 feet to the left of where it started. This is what we call displacement. It's not the total distance, it's just how far the particle was displaced. Actually the net change from start to finish. That's all that we found with this integral. In order to find out specifically how far that particle has traveled over this entire trip, we have to take a much closer look at it, and that's what we'll do tomorrow.